Good morning, ladies and gentlemen. Today we are going to discuss something that we call the chain rule. And the chain rule is how we take a derivative of a function that is basically a composition of multiple pieces. So like in the first little thing I've got up here, I've got f of x equals 3x to the fourth plus 2 quantity squared. If we were to try to take the derivative of this function, we would have to take the 3x to the fourth and write it out twice. Then we'd have to use the product rule. So if that's what the function equals, then our derivative would be, according to the product rule, 12x to the third, and then you get 3x to the fourth plus 2 plus 3x to the fourth plus 2 times 12x to the third, and then you can group your terms and you end up with something like 24x to the third, 3x to the fourth plus 2. Yeah. So, I mean, yeah, you could do that, but what if the function gets a little bit bigger and more annoying? I mean, to the fifth power here, are you going to sit here and write this guy out 5 times? And then the product rule for something that has 5 pieces of the product? That's crazy. What if there was an easier way to do it? Okay, so first, the easier way, I'll show you what the easy example. I'll just tell you the answer. It would just be 2 times 3x to the fourth plus 2 times 12x to the third, which equals, the same thing. So I must have done something, right? But what I was really trying to show you was the process without explanation. Okay, let's do this one without explanation. So it would be 3x to the fourth plus 2 times, now to the fourth power, times 12x to the third, which then simplifies to, that's supposed to be a 60. It did come out very nice. And that's not erasing. Let's try that again. 60x to the third, and then 3x to the fourth plus 2 to the fourth power, like that. So then the question is, what the heck did I do? Well, here's the chain rule. You got to think of it like a composition of functions. You've got an inside and you've got an outside. Now, if you remember how Fog and Goff is written, this is the inside piece. And the F is the outside. So it's F prime with G still inside of it times G prime. The derivative of the outside with the inside times the derivative of the inside. And here I've got a little picture of nesting dolls, because you can think of the functions kind of like that, where each one has a layer. And you're going to take the derivative of each layer only once. And then you move on to the inside piece. So you start on the outside and you go to the inside as you're taking derivatives. Now, so far, my 2 examples here only show you ones with just an outside and an inside. Very basic chain rule. These can get quite complicated. And as we go through some of these examples here today, you're going to see how they can get messy. So don't quit on the video. Watch till the end, because some of the examples get pretty crazy. But first, I'm going to take a second here, and I'm going to go to this guy right here. And let me just erase that little part. It's annoying me. All right, there we are. Good. All right, so just applying what I was just talking about. So the outside would be the fifth power. The inside is this 3x to the fourth plus 2. So what do you do when you're taking the derivative of something to the fifth power? You bring the power in front and subtract 1. That's where I got that 5 and the 4 from. That's where this piece and this piece came. Then I kept the inside part the same. All right, so I took the derivative of the outside, that's the power rule with the 5, then becoming the 4, and then keep the inside the same. So that is like this step here. Think of him as the F prime and the G in my rule that I have on the next slide. And then I needed to go work my way in. I needed to take the derivative of 3x to the 4th plus 2. So this is my G prime. That's the derivative of my inside. Notice when I took the derivative of the inside, I discarded the outside, the 5, the 4. They didn't matter anymore. All right, I already took their derivative. You only take their derivative once. By the way, when I say discarded, it doesn't mean it has nothing to do with my answer. It just means on the next part of the problem, I'm looking to the derivative of the inside. Then finally, what I did in the next piece is I just simplified 5 times 12 is 60. That's that. Okay, so let's jump around here. Oh, there we are. Now, I'll go back to my original blue. All right, so the cosine is the outside. He's the outside right here. He's the outside, and he's the inside, the whole thing. We only have 2 layers. We've got a cosine and that guy. All right, so we're going to take the derivative. F prime is going to equal the derivative of cosine is negative sine. So you write negative sine. Keep the inside the same. Don't do anything to the inside yet. Then we go to the derivative of the inside, which would be 8x plus 3. Now, just for simplification's sake, and so that you know, you can bring anything algebraic in front of a trigonometric piece. You know, like how you guys learn like 2 times x is 2x and not x2. You know, that order that we like, always put the coefficients in front. Similar. The trig part goes after any algebraic piece. Sometimes people will try to tell me, oh, can I multiply these? No. This guy's inside of the sine. So, no, you can't multiply the 8x plus 3 and 4x squared plus 3x. And there's your answer. All right. Now, here's a case of another one. But before I even get to it, I probably need to write it out a little bit better, make it a little bit more obvious. So a square root would be to the 1/2 power. By the way, I want to notice the change in notation here. I call this function y, and I'm looking for y prime. What I do is the exact same thing. What I call it is what's different. All right, so now the outside part would be the 1/2 power, and the inside part would be the 6x to the 3rd plus 10x. All right, so let's go for it. The derivative of the outside, so that makes the 1/2 go here. Keep the inside the same. And now when I subtract 1 from a half, I get negative 1/2. You know, because 1/2 minus 1 is negative 1/2. Now we need to take the derivative of the inside. Okay. All right. Now you see that negative exponent? Oh boy. Negative exponent means he moves to the bottom. All right, so your final answer, well, actually, hold on. We'll talk about final answers in a second. I don't get ahead of myself. You can take that 18x squared plus 10. He becomes part of your numerator because he does not have a negative exponent. The 2's down in the bottom. And then you have this square root 6x to the 3rd plus 10x. And then my frizzy-like friend last week asked me, it's okay if we have radicals in the bottom? And I said, sure, Skippy. I think it was you, Frizzy. I can't remember. It was somebody. Oh, wait. I do see this 2 can cut into both numbers up top there, so you can do that. It has to divide into both in order to simplify this out. And that's where some people are going to get confused on simplifications. You got to look and hunt down your answer sometimes in multiple choice. All right. Let's see if we can... oh, okay, tangent. There we go. Good. And we got f prime. So, all right, let's go for it. F prime is going to equal the derivative of tangent is secant squared. Secant squared. And then you put the 4x plus 1 in for your angle. And then that's just going to be times 4. All right. So now the derivative of tangent is secant squared. Keep the inside the same. Then the derivative of the inside is just the 4. And then you just simplify your answer. Okay, these last two examples, get your tissue box, you're going to cry. Because we don't have just an inside and an outside. We've got an inside, an outside, and a middle piece. It's like crazy. But first, let's make sure you could see it. So that cube root, if you recall, is 1/3. So that is the outside piece. That's the outside piece. The sine then is the middle. And the 2x is your most innermost piece. So those are your layers. You got the cube root, the sine, and the 2x. So working it out, the derivative of the outside, so you're going to have 1/2, not 1/2, silly goose, 1/3, and then we have sine of 2x. And when you go 1/3 minus 1, you get negative 2/3. So that's the derivative of the inside. I'm sorry, the outside. I misspoke. Now, the derivative of the inside, the derivative of sine, is cosine 2x, keeping his inside piece intact. And then finally, the last part is what's the derivative of the innermost piece? The derivative of 2x is just 2. I want to point out when I did this that, once I took the derivative of the piece, whether it was the outside or the middle piece, when I went to the next layer inside of it, I didn't bother with it again. I left it there, but I didn't bother it. Before anybody asks, this is not negative. Okay, let's clean up the answer here. So my answer would be something along the lines of, let's see, I got a 2, cosine 2x in my numerator, and down below, I got a 3, and there's a couple ways you can write this. Simple way you could write this would be something along the lines of this. Let's see. You could do that like that. Or if you're deciding to bring the whole radical stuff back in, you have a cube root of the sine squared of 2x. Remember, when we write exponents, like a square, it goes after the word but before the angle. So it looks something kind of like that. Alrighty, last one to look at. And there you go, up dy dx, slightly different notation, but it's the same process. Okay, now I do want to clarify this because sometimes people get crazy. If they don't know where that 5 fits in. That's sine to the 5th power. So to make it easier on you, you might want to take that 5 and drag him all the way out like that and put sine in like a bracket. It makes it easier to see who's the inside and the outside. So the outsidemost piece is the 5. You will deal with that first, the power, that is. Then the middle piece is the sine, and the innermost piece is that 3x to the 4th plus 2x. All right, let's get it going. Why hesitate? All right, so like I said, the outermost piece is the 5th power, so you start off, you got 5. Then I'm going to keep that bracket. Just let's go get plus sign. And that's to the 4th power. Times, now let's go, the innermost part of that is the derivative of sine, which is cosine. And keep his innermost part there intact. That's supposed to be 3x to the 4th. And then finally, the innermost part there, that is going to be 12x to the third plus 2. All right, let me look. What can I clean up here? Well, the one thing I am definitely going to clean up is I'm going to take that 5, and you don't need to worry about distributing. You could. You could turn that into 60x to the third plus 10. I just took that, brought that in front. Then we have sine to the fourth power, 3x to the fourth plus 2x. And then we have cosine x to the fourth plus 2x. And that's it. All right, guys. I'd like you guys all to stay safe. Take care. Yeah.